Hi Chem Peeps, this is video 3 in Hess's law under thermodynamics. So let's look at this sample problem. It says calculate the heat of reaction for the formation of 2 moles of solid carbon from the decomposition of carbon dioxide. So basically what we're going to be doing is we're going to be taking these first 2 reactions that we have enthalpy for, and we're going to add them to get this final reaction. So I always tell my students, look at your final reaction and see where the different pieces are found. Now, carbon dioxide is actually, it's a reactant here in the final answer, it's actually found in 2 spaces, one in reaction 1 and one in reaction 2. One's a reactant, the other one's a product. I'm not going to actually focus on that one first. I'm hoping that I can deal with both reactions by looking at the other pieces. What do I mean by that? Well, I have carbon here as a product. Where's carbon in the solid form found in the first reaction, or in the first 2 reactions? Well, it's actually found in the first reaction as a reactant. There is 1 mole, and there's 1 mole here. And they're on opposite sides. So I am going to have to turn around this reaction to get the sum to have the carbon on the correct side. Where's the oxygen found? Well, the oxygen is found on the reactant side in reaction 2 here. There is 1 mole of each of these, but they're on the wrong side. So I will also have to turn this reaction around also. So when we rewrite the reaction, I'm going to take that first one and I'm going to turn it around. I'm going to have 2 carbon monoxides forming carbon solid plus carbon dioxide. And since I am turning it around, I have to make a negative of whatever the delta H is. So that positive 173 now becomes a negative 173. The second reaction, we also want to turn that one around. So if I turn it around, I'm going to have 2 carbon dioxides in gaseous form here, forming 2 carbon monoxides in gaseous form, plus an oxygen in gaseous form. Now I turn this one around, and so likewise the negative 567 is now going to become a positive 567. So let's see if we can simplify the reactions at all to add to get to the overall. Well, looking at this reaction, I can see that I have 2 carbon dioxides and 1 here. So I'm going to completely remove this one, and I'm going to reduce this one to 1. I can also see that I have 2 carbon monoxides on the reactant side in reaction 1 and 2 carbon monoxides on the product side in reaction 2. And so the sum of that is going to reduce those out. So if I add the reaction down, I'm going to get 1 carbon dioxide forms 1 carbon solid plus an oxygen gas. Okay, and that does match the overall here. And so I can add my enthalpies from above, and I'm actually going to get a positive 394 kilojoules. Now, before we stop, I want to go back to the problem. It wanted to know 2 moles of carbon solid, and we have 1. So my final answer is going to have to be multiplied by 2, and so the final answer is going to be a positive 788 kilojoules for this reaction. Okay, so there's application of Hess's law. Find my last sample problem, TikTok and YouTube at Chem Chats.